Okay, I guess we're just about ready to begin. This is our second session of team projects, and the first team presenting in this session is Team 2, iMedix.
Hey everybody, I hope you keep enjoying your lunch. You don't have to stop for our sake. But like Professor Pisano said, we're Team iMedix, and we comprise of Kholood Tabash, Gregory Zoeller, Nick Dougherty, myself, Kenneth Zhong, and Hsiao. So first I want to talk about the need for iMedix. So according to a study by McGill University, up to 50% of adverse events that occur in hospitals are preventable, and preventable through means of better communication. So a lot of these pitfalls happen when there's poor communication between the nurses and the patients. So from that, we decided that we would go and talk with hospitals in the area to try and find out more about what would make a really great communication tool. So we took it upon ourselves to go to Mass General Hospital and to start shadowing in the hospital, be a fly on the wall, see what it's like in a hospital environment. And specifically, we went to the stroke ward at Mass General Hospital as well as the RACU. So from that, we found a lot of great ways that we can improve this patient-nurse communication. So from our beginnings, we had a static application. So it was just one application, and it was just, if you pushed it to the hospital, they're only getting one way of talking to the patients. So it's super simple, and it was a means of communication, but it wasn't exactly what we wanted. So we decided to change things up. So we wanted to build a dynamic application. And so what that means is that every patient could potentially have their own custom-made application to them. And we do that through an API system that sort of supports our application. So for us, we really wanted a customized application, and we wanted it to be a truly better way to communicate. And we did that through our collaboration with MGH. So the real focus was to take this project and move it towards something that's really going to make an impact beyond just this course. Oh, sorry. About that. All right. So what we have now, these are our requirements. So the first thing that we have is our easy-to-use web application. So how are the nurses going to be able to see what the patients are sending? So we have a web application that will sort of take in these requests and show it to them. Next thing is we have to secure the iPad. We can't just have them floating around. We have to make sure that they're held to a bed or they're on a mount that can sort of come in and out from the patient, and also so the patient doesn't need to hold it the whole time. We have to make sure that we have picture-based icons. We want to make sure that it's super easy to understand the application, regardless of whether or not you can read, or regardless of whether or not you can really see well. We want it to be something that's super easy to understand. We want to support multiple languages, because it's not always easy to figure out what somebody's language is if they come in with a stroke. They may have difficulty speaking, so it's really easy to put this, implement some languages that people would be able to communicate better with. We also have an external input device. So say you're blind. You can't see our iPad application. It's going to be very difficult to touch the icons on the screen. So what we decided to do is we made this third-party input device that will allow you to tab through our interface using a really tactile button press. And this is also used for people that might have limited sight, and also somebody who would just much rather just hold a button, hold something in their hands. We're going to give them that opportunity. And the last thing we have is voiceover. So again, for somebody who's blind, they're not going to get visual feedback on the screen. That's kind of useless. What we want to do is speak back to them. So speak back their requests and let them feel comfortable with the experience. So with that, we wrap it all up into this new solution. So just as a brief overview, we have our input device at the bottom of the screen. When you push the button, it's going to send a request to our iPad application, and then from that, we're going to send the request back off to our nurse's application, and the nurse will be able to then say, oh, your head hurts, now we're going to go send a nurse your way to come help you out.
So great. So how do we develop this application on the iPad? Well, the first thing that we use is we use a development studio called Titanium Studios. And this is a product that allows us to develop quickly and also on multiple platforms. So one of the things that we were debating was whether to do it on an Android platform or on an iPad. So we use this development kit to essentially be able to push this to either an iPad or an Android. But right now, today, we pushed it to an iPad because we thought that the iPad had the best user experience. So in developing the iPad application, we had two major things to consider. We had to find out how are we going to build this app dynamically, and how are we going to enhance the user experience. So really make it very easy to use by the different patients. So by building it dynamically, we're actually storing the information to build our application on our server. So what a nurse will do is that a nurse can select different options, select a different application, and then the iPad will send a request to our server and fetch all the data that it uses to essentially render it out. And this is really useful for many different applications, like say a patient has high blood pressure or say a patient has had a stroke. We want two separate applications that can really handle this. So what the nurses can do is on their end, they can design an app for a specific patient type, and then from the iPad app, they can pick what they want, and that application will be built on our iPad. So to enhance the user experience, we really wanted the whole package with voiceover integration, integration with our device, and just really making it as easy as possible. So with the picture icons, patients can either select directly from the iPad itself by clicking a button. They can tab through the different options using the third-party input device, and this is synced with our voiceover so that it will actually say the button name back to you, and then when you click to submit a request, it will actually acknowledge. So you don't have to have your eyes open to interact with our iPad. And finally, the last mode that users can interact with it is more of an application-driven development. So we have a patient that has limited mental and physical capabilities that the application itself will go through the different options on the iPad, and then the patient, all they have to do is hear something that they want to select and then choose it. And so this really helps us build out all these different options. And so here's a picture of our app in the different selection modes. And so a nurse can go through, build out a custom app for you, and then have it be sent for the patient to use.
Like previously mentioned, we want our iPad application to be available to everyone. Patients who have limited mobility can use this input device to interact with the iPad. This device is connected wirelessly through Bluetooth with the iPad. And by pushing the buttons, you can transmit data to the iPad. What you see on the screen is the case for our device. Each button corresponds with the action. The two side buttons will toggle between icons left and right, and the middle button will select it. It's very easy to use, and the buttons are really big and very easy to press. Inside the case, you can see the main components of our device. It consists of the RN42 Bluetooth chip, multiple push buttons, and the Arduino Uno R3 development board. The Bluetooth chip is programmed with the HID profile, which allows it to be able to connect with the iPad and be synced as a keyboard. There are multiple push buttons, and each pair of these buttons are connected parallelly, so when you push it, it will send one ASCII character. We have these multiple push buttons because from the earlier slide, the surface area of each button on the case is much larger than these individual buttons. And the Arduino development board will send a hex code to the RN42 serially, which the Bluetooth chip will interpret, and a corresponding ASCII character will be sent to the iPad.
So our server is what really manages our entire system. Everything goes into the server in order to the application to basically run successfully. So in order to develop the server, we used MySQL and PHP. We have, let me point out to you the most important aspect of our development for the server is that we built our own database API, which is based on object-oriented principles. So when creating or when MySQL statements are created, they're going to be created dynamically. This basically makes it easier for the other developers on the team. They don't really need to know how to use MySQL. They can just use the functions that we created in order to develop their parts. This API is sort of similar to the object relational mapper, I think ORM. That's most commonly found in web frameworks today, such as Django. So we have 5 projects. The first one interfaces with the MySQL database. The second one basically maps our iMedix classes to the database's tables. We have 4 main iMedix classes, which are patient, nurse, request, and application, which are basically used to build the iPad application and also are used by the web application to display information. The third project is what basically handles communication between the iPad application and the web application. It's based on a REST protocol. It handles all incoming HTTP requests from the iPad app. The final 2 projects are media-based. We have one that handles image uploading and conversion to thumbnails, and one that handles one that uses Google API text-to-speech API to basically create audio files for each button name. So it takes the button title, creates an MP3 file, stores it, and then streams it to the iPad app. So to summarize, we have incoming HTTP requests from the patient's iPad application, and then the first three projects that I just mentioned basically handle and process and store all the incoming requests. Then the nurse's web application can basically fetch information and display them. One of our deliverables is a mount and a movable arm that holds the iPad. So we need a mount that's attachable to a patient's bedside, for example, and an arm that moves in multiple directions while holding more than one version of the iPad. Now the purpose of this component is just like the entire project, to make user experience or the patient experience as easy as possible.
So the next part of the application is how do we get the patient requests to the nurses? The nurses rely heavily on desktop computers at main stations around each ward. Each ward will be able to log on to this dynamically by hitting either a local host URL, or we can even host it in the cloud and have the server set up in a way that will allow us to set up more than one ward at a certain time. We used a combination of a couple things. The first is we made it a 3-layer web application, the top layer being the HTML and the user interface, the second level being an AJAX, asynchronous calls to backend PHP that interfaces with the API. The API would be the third layer, which allows us to do the MySQL statements without actually understanding the back end. Another goal of our system was to prevent unwarranted access and provide security for all this information. Our use of AJAX is able to prevent some of the more simple XSS attacks, and we have a password system that will check the more on a basic level as well. It'll check the cookies and will make sure that you've been authenticated into the system before letting you go and see any of the actual information. So the website is set up as such. I know you can't see the bottom pictures, but the first picture is the app builder, which allows you to dynamically update and create new applications per patient as they come in. We can also bring in pictures and change whatever we want to in the base classes as well. So if you're in a certain type of ward, you can bring in the default to be a certain different thing. The nurses and the patients are basically the same thing, except they do it for different groups of people. The nurses are nurse profiles. They tell you where the nurse is located, if they're on duty, off duty, something along those lines. and also what patients they have. The patients give you the information of the nurse they're in, the room they're in, and also the most recent requests that they've made. Down lower, you can see the requests. It's also accessible by the monitor function up top. This will give you 3 separate lists. The top list are the requests that have come in and been unhandled. The second list is the list of currently processing requests that haven't quite been handled yet, but have been allocated to resources. And then the bottom is the completed requests that have been gone through and been completed to satisfaction within the ward. The next site over is our custom search function. We can search within the database to provide all the different objects that are in there. Each object is then clickable to see their, it's then linked to their profile or to the actual request that it's been made. The last one is the upload picture page. The upload picture page allows us to bring in pictures and use them within the app builder to dynamically create those apps. So what happens when we put everything that we've just described together? We really get a dynamic, integrated, and fully functional system that allows us for patients to communicate with nurses, even though they have great different disabilities, or even if they don't have disabilities, but they just can't speak English as well as they need to, and they can't get their wishes across. So for every patient, there can be a different application that is addressed by different means of input. Some of them could have these input devices, some of them don't need them. Then they go through the application to the server. The server then takes those requests, puts them into the nurse's application in a way that's easily readable and easily parsable for anyone who needs to know. So what is it actually going to look like? What is an actual implementation of this going to be?
We connect the Bluetooth device to the iPad, and we click the buttons to send an input.
So from that, this nurse picks up the application. They type in their login information. All right. They choose basically who the patient is and what type of app mode they want to have. They're going to go ahead and then choose the custom app that's specifically made either for that patient. So this is our custom application page. And then from that, take the iPad, you hand it to the patient, and then, or they could take the input device, and they'll just tab through the icons on the screen, and they're just going to go ahead and select their request. So our patient seems to have a head injury, so he's going to send that away.
So once they select this head icon, it's being sent to our server and stored in our database so it can be accessed in the nurse's station.
The nurse will then log in using their given credentials, navigate to the request page at the bottom left corner, and they'll find the request at the very top. You can hit assign, which will move on to the next level of, it'll allow it to move on to the next level of status, and you can also delete it if need be. We have very high-end patients.
Finally, we would like to thank our classmates for putting up with us and our friends and families, and of course our customer, Professor Morse, for providing us for this great opportunity and all the resources that we needed. Of course, Professor Pisano, Professor Montazam, and Maverdick, and all the TFs. I'm looking for you. And all the TFs that helped us throughout the year, actually. And of course, we would like to thank everyone at MGH for helping us. Thank you.
So, in a hospital setting, one of the things that's critical is reliability. If I'm dying and I press a button, and I think that the nurse is coming, and the nurse is coming, that's a problem. What do you do to address reliability?
That's a great question. So one of the big requirements of the hospital was that we weren't replacing the call bell system. So it's to be used as an aid to the call bell system. So one thing that we didn't really touch on, you still have that call bell next to you. So if you are dying, you're recommended to select that. We originally had an emergency button on the screen, but the hospital asked us to remove that because they don't want that on us. That's not our responsibility. So I know that's kind of a cop-out answer, but it's one of those things that we didn't really work on because the hospital told us not to. Yeah, go ahead.
Also to add on that, in terms of reliability, we did run a test script just to make sure that all the requests are inserted into our database. So we would hit it with one request, 10 requests, and all the way up to 10,000, almost all at once. And all of those requests came back positive. They were all checked for, so we had 100% reliability for them all essentially being sent all at once.
Have you done any kind of realistic testing in a real ward setting where you go to an Phasic patient and you give this thing to them and say, how reliable can you?
It's definitely been something that's been a big focus of ours to get there. And what we really wanted to do was, originally we were going to try and do some testing during the year, but we elected to just really observe and sort of figure out what they would want, and then just get a polished product that we could go and show to them, because we didn't want to come in there with something that we weren't happy with. But I think now we're at the point where we can start doing clinical testing.
Yeah, but if you look into it all, what your customers would be willing to pay, one of my concerns would just be the upfront cost.
Right.
The iPad, voice recognition, the server, the mount.
You want to talk about? So one of the ways that you can market this, and we've done a little research into it, is current systems that mimic this are in the hundreds of thousands of dollars. So, and none of them are covered by Partners Healthcare or any of the big HMOs or PPOs. So, since in the very beginning we showed you a slide that said 50% of accidents in hospitals can be related to communication. So, if you market this towards PPOs as a 1/5 the price of those things, which will also prevent patient miscues in the hospitals, you can get not only the hospitals to be interested in this at a lower cost, but also the HMOs to sponsor this through your premiums. And another thing to sort of tie onto that, the specific ward that we were working in, they just implemented the Volte system, which is it's an iPhone system that basically is it's another nurse paging system basically. It doesn't have the amount of functionality that we have, but it's something that they just purchased, so it shows that there's similar technologies coming into the hospital. When we did speak offhand, there were a couple estimates thrown out, but we're not going to get too much into that.
Do you guys have to make any additional considerations towards security, medical information to get this to a point where you can actually...
So right now we're actually working with Partners Chief of Information Security, and he's really kind of helping us push this along within that regard. I know there are HIPAA standards that we have to require, but I believe they're only required if we're using full name, social security number, along those lines. This will just be kind of a localized system, so I think we can kind of get under that. But at the same time, one of our big concerns moving forward with this is that we want to get it as secure as possible.
And the information we're displaying is not extremely sensitive, and we'll work with MGH in this, deciding what sort of things we can put on it. And it's just, I think we did have a couple of security layers, so we do account for basic security measures like MySQL insertion we have covered in the database API, and we also, like Greg said, we use a lot of AJAX requests that kind of prevent any cross-site scripting.
Right. Yeah. Professor.
I am the patient who had a stroke-related injury, and I was not able to speak, and this would be a godsend.
Yes. Thank you. Oh, sorry. This one.
Given that this is about communications, did you leave hooks to tie into the patient chart information so that the nurse would have access to meds and recent tests and things like that?
Those will be along the same lines as the HIPAA requirements. We can't really get into too much patient detail. When we set up the apps, and while the nurses set up the apps through the app builder, they can take into account that this person can't have this type of medication, this person can't have gluten, this person can't, this person has diabetes, and high sugar foods are probably going to be off the menu. So you can really kind of customize that in a way that'll help you without revealing too much patient information. Yeah. So one big reason why we're not going straight for sort of the best answer is because it takes a long time to get a product into the medical community. So we've been sort of working with them as sort of the fastest way that we can get in, and a lot of that is by just being this communications tool. And like once you're established there, you're a company that they can trust, then you can sort of build upon that and add more features. And that's sort of what we're looking to do.
So you think a product like this could be used in a skilled nursing facility where overnight there's like one nurse for an entire ward of people and they're all sort of trying to get her attention. Right. And even if all of them can speak, except that there's no good tool for addressing that.
Yeah. Like one of my favorite aspects about it, so say you want a Gatorade, you're sitting in your room, you're really thirsty. Rather than waiting for the nurse to come to the room to ask her to get a drink, then having her leave and come back, you can make the request so that she's already there in the room for you with what you want. So that's going to save a lot of time in the hospital, and hopefully that'll help make a single nurse's life a lot easier.
Another way of marketing this as a quality assurance for nurses. You have all the log data. You can record average time to this can be sold to nurse managers. I think we should.
Bring up the glamorous part of what you have for vision or recharging all the iPads. Are they always plugged in?
That's a great question. So there's a couple things that we did. Originally we were thinking of having it plugged in all the time, but from observing in the hospital, that's not really going to make sense because having an extra wire in there that's attached to a mount, it could be something that you trip on, it's just going to be in the way. So what we're going to do is that unfortunately, it'll be the nurse's responsibility to check to see how much battery life is left, be able to pop it off and replace the iPad. Unfortunately, that's what it's looking like right now. Hopefully we'll be able to, once we get more integrated, we can find some other solutions.
Another possible solution is that we were looking into other ways to create our bedside mount, asking around at manufacturers, see if they could develop something like this for part of the design of the iPad arm could possibly work is have the actual charging station wires inside the mount itself and then leading to a wall socket.
Or senior project for next year.
Cool. All right, thank you.